Hey guys, welcome back to my mill project. As you can see, I've got most of the wiring done in my control cabinet already. As I previously mentioned, it was very difficult to video point-to-point wiring in this cabinet. Now that said, I'm going to do a series of videos using the all-in-one DC install manual, and I'm going to use a dry erase board, and I'll go over key assemblies in the cabinet, if you will, so that you guys, it might help you as you move along in your installation. I wanted to go over a few things in my cabinet. You know, if I had to do it all over again. You know, I bought a cabinet and I really thought that this cabinet was going to be plenty large enough. I think I got a 30 inch tall cabinet by, I want to say it's 20 inches wide. Let me grab my tape. "24 inches wide, 30 inches tall." Now, as you can see, I mean, everything worked out, but it's kind of tight. And I guess if I had to do it all over again, I would have got a 36 inch tall cabinet so that I could have put a wireway, this plastic Panduit stuff, so I could have put a wireway across this area here. I just didn't have the room because of my two VFDs. And here's the knee VFD and the coolant pump. This one VFD is a 2 horse. This is the 3 horse for the spindle. This is for the knee and the flood coolant pump. I've got that in there, and I just had enough room. So fortunately, it doesn't run very often, only when I need to raise and lower the knee, or if I'm going to run flood coolant, which I highly doubt I'm going to run flood coolant, but I wanted to wire the machine so it was there. Again, you know, let's kind of go over some things in my cabinet. These are the fuses. These two fuses are coming from the disconnect. It goes right into the fuses. These two fuses are the 240 volts incoming. This fuse here is the 120 volt incoming for the control itself. This is my remote start-stop contactor. You know, I've got buttons up on the underneath the monitor, and to start and shut down the machine. It's more of a convenience, really, because I usually have a drill press right in this area of the mill. My shop here is pretty tight, so I've got to take advantage of all the floor space I can. So that's what that is. And then here's the bus capacitor for the all-in-one DC servo power. And then it's probably very difficult to see. You might be able to see it here. Is the bridge rectifier and the Inrush current suppressor here. It was very much needed because it would trip my 20 amp breaker, dedicated breaker to this. So that Inrush current device goes on the line side of the bridge. So one leg of the AC goes through it, and then the other leg from the Inrush current device plugs into the bridge. So that takes care of that. Moving over here to the left, I have some just simple fuse holders here. One of them is control voltage to the start-stop station and the start-stop relay. I've got a 1/4 amp 120 volt fuse in there. And then the next fuse I've got for the cabinet fan. And then I've got another fuse here for the work light. My work light, when this contactor fires up and provides AC to TV1, will turn on the work light, will put voltage to the work light. And what I did on this is I put on the side of the cabinet, right here, I put a weatherproof receptacle box, and one of them I split. I don't know if you know you can do this. On the side of a receptacle, there's a tab between the two hots. If you break that off, it allows you to have two separate circuits there. So one circuit, I've got my work light on top, and then the bottom circuit is the lube pump. So they both plug into that. This is my flood coolant relay. It's a 3-pole relay. It's got 5 amp contacts on it. This actually is CNT2 on the all-in-one DC schematic. It's wired just like it shows, with the exception that I did not use the overcurrent relay on my setup. What I have is a fuse block in the original electrical cabinet to the mill. 3-pole or a 3-position fuse block, and I'm just going to put in 1 amp time delay fuses. The coolant pump draws, I think, 0.6 of an amp at 240 volt 3-phase. So I'm using fuses on mine. The next one is CNT1. It's the e-stop contactor, and you know, the things that are going through it is the positive and negative DC power to VM minus and VM plus on the all-in-one DC, the bus power. And let's see what else we have on here. I'm trying to remember. Let me look at my schematic here. Well, anyway, we'll go over that with when we go over the dry erase board. I'm trying to look at my schematic and see what we got. Output 7, output 8. Okay, spindle. The spindle disable is on here. So if you have an e-stop, it disables the spindle. And then the other one was the flood coolant pump. That's right. So if you hit the e-stop, it shuts down the flood coolant. So that's what we're using. Let's see. So I'm using everything on there. And then this is TB1. Of course, this is kind of the heart of the setup. You've got AC positive on the top. You got AC negative. You got DC ground. You've got 24 volts of DC and 24 volts negative on here. The 24 volts DC is coming from the Meanwell power supply. We're using that 24 volt DC circuit. On this side, we're landing all the commons for the limit switches. So again, we'll go through some of those. Of course, we've got the all-in-one DC here. We've got the power supply for the all-in-one DC primarily, and then we're using 24 volts. One of the other things that I wanted to cover is in the manual, it goes over putting the right resistor in the all-in-one DC depending on which what voltage you're going to be using the inputs. So if you're using 5 volts, you have to change your resistor to the 470 ohm resistor. If you're using 12 volt, you know, control circuitry to the inputs, you use the 1K ohm resistor. And if you're using 24 volts, you're using a 2.2K ohm resistor. Let me go ahead and take the panel off the all-in-one DC and I'll show you where those are at. The manual's pretty good about describing where they're at. The 24 volt resistor was in on my all-in-one DC when I got it, so I left it that way because I just preferred to keep it very simple and use 24 volts on everything. Okay. Here are the 4 resistors. There's one here, there's one here, one here, one here. They control banks of 4 inputs. So the first 4 inputs are this one, the second 4 are the second one, third bank of 4 is the third one, and the fourth bank of 4 is this fourth one. You can mix and match in banks of 4. So if you had 5 volt inputs for some reason, you could put some, you know, your 24 volts on the top, change the resistor, and put 5 volts here and so forth. I just kept it simple. I just went with 24 volts on all my inputs. I'll give you a look at what the resistors look like. Very tiny. Here's one of them. It's another one. Now there are 2 black resistors. You can't go by color. You have to read the numbers on the resistor so that you get the right ones installed. So anyway, that's your those are your resistors that control your input. The manual says you could damage the all-in-one DC if you don't change those resistors. They're called SIP resistors, single inline package, because they're straight and they're in line. So make sure you read up on the manual depending on what you're going to do. The manual also goes over syncing and sourcing. You know, I just followed the schematic for my limit switch inputs. So that's just the that's the route I chose to go. that way I don't have to make very many changes to the schematic. For limit switches, I didn't see any advantage of syncing or sourcing one or the other. Syncing or sourcing just basically means, well, let's just read the manual. Sourcing, connecting the inputs to power is sourcing. The negative lead of the power supply must be connected to common. This is demonstrated in inputs 1-4 figure 523. And here's the guide here that kind of goes over that. And then syncing, by connecting the inputs to ground, is syncing. The positive lead of the power supply must be connected to common. And that's what I did, where I'm syncing. See if you can see that. So 24 volts is going to common, and then it feeds out to the limit switches. So 24 volts goes into the common bus of the all-in-one DC inputs. Then it goes out through the switches, and then it comes back from the switches to 24 volt DC common. And that's the way I hooked it up. That's the way the schematic showed it, and that's what worked for me. Now you may have to change things if you're not using simple dry contact limit switches. Maybe you're using say an optical type relay or optical sensor, and you have a different voltage requirement. A lot of them you can get where they're 24 volts. They operate on 24 volts. Sometimes they're syncing or sourcing, so you know, everybody's situation is going to vary a little bit. Depends on what you're working on. Again, I chose to follow the schematic. So that goes over the resistors and the importance of putting in the right ones. We talked about the power to the, they call it the cat board, because they have their board sitting right on top of the capacitor. They have their, the bridge on top of the capacitor. They talk about wiring that up, and again, both legs are going through CNT1, which is the e-stop contactor. So it comes off of here, goes down, and it goes into the line side of CNT1, and then it comes out of CNT1 and goes up and around and into the all-in-one DC VM 1 and 2, or VM minus and VM positive, VM minus being the top, VM positive being the bottom here. So that's the way that works out. We'll go over the e-stop circuit in general on the dry erase board, but the e-stop switch itself has two circuits in it. One, the e-stop switch is in series with the e-stop control circuit, e-stop relay on the all-in-one DC. It's in series with it, and then it goes to the contactor and then to common. So 24 volts goes in, goes through the e-stop button, and then it comes around, goes through the all-in-one DC's relay, e-stop relay, and then comes out and goes to this. So it's normally energized when the machine is on. Everything's closed, so that relay will close, voltage will flow from the bus capacitor to the all-in-one DC's servo input power. The power will be allowed to go through to the flood coolant relay, and so forth. So the e-stop relay is pretty important, but that's kind of a verbal overview of that circuit. It's an important circuit. The other part of the e-stop button is basically a direct input. So 24 volts is going to the input on the all-in-one DC, and then it's coming out, going up to the e-stop button and coming back to common. So if the e-stop button is pushed, it opens that circuit, and the all-in-one DC sees an e-stop button active when that button's pushed. It opens the circuit. It's important to note that the e-stop button has two contacts and they're both normally closed. So that's the two parts of the e-stop button, just kind of verbally going over that with you. Wiring servo motors. I'll be doing that next. I've got my motors and my encoders right here. I got my motors mounted on the machine. My servo motors are mounted on the machine, but they are not belted to the machine yet, meaning, you know, there's no connection between the servo motor and the machine yet, and that's very important. During testing and setup, we want those motors mounted so they're not rolling around as you're turning them on and off and doing testing. So I'll be hooking up those next. In fact, you know, I'm going to take care of that right now, and I'll get them wired up, and I'll be right back with you. Okay, I'm on the Z, and the bottom terminal is the shield. The next terminal up is negative. And the top terminal is positive. Tuck the cable in there. Okay, we've got our servo motor voltage connected. Okay, it says with the servo motors connected, confirm continuity between the motor chassis and the all-in-one DC chassis using a DVM. So, let me get my multimeter and we'll do that. So they just want to make sure that we have continuity between the all-in-one DC chassis and the motor chassis. Getting a lead on the chassis of a Z-axis servo. And let's see if I can get this without disconnecting things. My shop's pretty small, so quarters are pretty tight. Get you guys up a little bit so you can see the multimeter. Okay, here we go, touching the chassis, and I'm on continuity, so I have continuity between the motor and the all-in-one DC. Of course, you would kind of expect that because the motors are bolted to the machine. Let's see if I can get another one. I'll get to the X here. Yep, there's X. Let's see if I can reach over here to Y. And there's Y chassis, the Y motor to the chassis all-in-one DC. So we're good there. Okay. So we've accomplished that task, and I'm on the page of wiring servo motors. Basically says danger and ungrounded servo motors and electrocution hazard. Always confirm continuity with a multimeter. Never remove the brushes from a DC motor. They do not wear out, and more costly damage may result by removing them unnecessarily. Okay, the next one it says connect each encoder cable to the proper all-in-one DC encoder input. Encoder input 1 corresponds with axis 1. Encoder 2 corresponds with axis number 2, etc. 4, 5, and 6 are for accessories. They can be used to connect additional servo drives to the all-in-one DC, such as a DC1, extra encoders to reduce error, custom manual pulse generators. These advanced uses will not be covered in this manual. That's understandable. So, it's kind of getting exciting. We're getting our encoders connected now. So we're going to start out with X, and one of the things that I did is with a Sharpie I put the axis on each on the shells of each encoder. get X taken care of here. Don't need to crank down on these screws, just snug them up so it doesn't come out. Next one is Y. Get down here a little lower so I can see this one. And then our last encoder, Z. I still have to dress out the cabinet. I'm not going to do that until after testing's complete, because you just never know if you find a problem or if you've got to add something, what have you. So I'll dress it out after we're done. We've completed setting everything up and the machine is actually operational, and there shouldn't be any more changes. So there's our 3 encoders, X, Y, and Z. So that's taken care of. And again, I'm following the manual here. Set current limiting. Okay, this is important. The all-in-one DC has a switch that I'm on 5.5, settings current limiting. The all-in-one DC has a switch that limits the maximum amount of current to the servo motor. The purpose of this feature is to prevent the all-in-one DC from burning up the servo motor. A hole in the cover is provided. Well, we've got the cover off, so we have access to it. To allow users to adjust the maximum current without having to remove the servo drive cover as shown in figure 5.5.1. For your reference, a close-up picture of the current selector switch is shown in 5.5.2. If the switch is black, on is away from the printed circuit board, while off is toward the printed circuit board. If the switch is blue, on is towards the printed circuit board, while off is away from the PCB board. Okay, so the limit switch that we're working with, let's see if I can get you guys to see it. Here's the limit switch, and you can see it. It's next to the relays, and then there's a header here. And then over here is the window that they're referring to, right here in the all-in-one DC cover plate. And then here's a table here. For optimal performance, it says use the tables below. Oh, let me back up. And I have the blue one. Here's the blue one right here. And it's right next to that header, and it's just below the relays. So it's right here. It says use the Appendix D to determine the correct settings for your motor. For optimal performance, the current on the all-in-one DC needs to be set at a higher value than the current rating on the motor. When adjusting the current, push carefully on the switch. The switch levers are plastic and can easily break off if too much force is used. So let's see if we can get to D. Okay, here's the page. Current settings for third-party motors. So in this column right here, I'm sorry, this is motor current constant stall rating, motor constant current rating, or motor current constant stall rating. Well, mine happens to be 6.7 amps. I have Glentech servos. So it tells you to go across the table to recommended. So it's maximum current. If I have 6, mine are 6.7 amps. So it says maximum current is 12 amps. So you go up. This is the recommended all-in-one DC current setting right here at the top. So we go across from 6 amps, and then we go across to recommended, and then maximum current. Now I spoke with the guys at Centroid, and I told them I have 6.7 amps, so I kind of fall between 6 and 7. So they said the recommended would be the 12 amp. Recommended could be 9 amp. So, you know, I could go with 9 amps on this. That's recommended. If it were 7 amps, we would be up at 12 amps. So, you know, I'm going to go with the 9 amps and we'll see how things go. They suggested 12, and that's maximum current. And 6 is recommended. So I kind of fall in that borderline. Let's just go with the recommended, which would be 9 amps on this one. So we go back to our table. And 9 amps should be off, on, off, on, off, on for all 3 axes, because there's a pair of switches. Switch 1 and 2 is for axis 1, axis 2 is switch 3 and 4, axis 3 is 5 and 6. So I'm going to go with 9 amps, and then it said, because I have a blue switch, if the switch is black, on is away from the PCB while off is towards the PCB. If the switch is blue, on is towards the PCB while off is away from the PCB. So on is towards the PCB, and I'm going with 9 amps. And all 3 motors are the same, so I want off, so switch 1 would be away. So I'll flip that. These are already alternating. Let's see, what was this? It was on, off, on, off, on, off. Okay, so it was defaulted. The switches are set to 12 amps right now. So I'm going to go off, on. So double checking here. On is towards the PCB. So I want to go away. So I go away on 1. Towards the PCB on 2, away on 3, towards on 4, away on 5, towards on 6, away on 7, and towards on 8. Yes, so 2, 4, and 8, I'm sorry, 6. 2, 4, and 6 are towards the PCB board. And that's what I've got. So that takes care of setting the current limiting on the all-in-one DC. We've got that taken care of. The next section goes over 5.6, goes over wiring the E-stop. One thing didn't talk about, and you probably see them here, these are the quench arcs, suppressors on all the relays. They're on the coils. They go across the coil of the relays. You can see them here, here, and then on my control relay there's a quench arc on it, so those are on there. Okay, so the next section is going to be wiring the E-stop. I've wired the E-stops, and then it goes over testing the E-stop. So let me get things situated, and so you can see the monitor as we do the testing.